see my screen?
Yes.
Yes.
Okay. So in our last presentation class, we did, actually in our last class where we did the slides, we went through the Arduino architecture. We saw the initial components within the Arduino system. And now we are supposed to continue looking at the more advanced features within the Arduino system, um, and this architecture, and how we bring in more components that are being utilized to implement the entire embedded system. So previously we had seen the architecture in the sense that we've seen different types of wires, we've seen the functionality of different types of ports, I would call them pins, on the Arduino board. So we'd want to continue and try again and see what are some of the additional components or additional pins that are found within the Arduino board. Apart from that, we are also been trying to give you some few exercises at the end of each and every class. I hope you've taken your time to look at those exercises. And I remember very well that in our last class, I also gave you some reading work that you are to go and see the additional pins and how they work. That is where I talked about the SPI, the serial peripheral interface pins. We did say that at the back of the Arduino, you will not be able to notice these pins when you're looking at the front end of the Arduino board. But when you look at the back part of the Arduino, then you'll be able to see the additional serial peripheral boards, which is the SS, the MOSI, the MISO, the C, the SEK port. So I would want you also to take time and come to the lab and have a look at the physical Arduino boards and try to identify these advanced components like the SPI, the AREF ports, the TWI, and actually the serial ports. So you'd look at them maybe from the front end when you are doing configuration, but when it goes to the advanced component, you look at the back, then you'll figure out that there's additional pins which are not labeled in front, but they are labeled at the back of the board. So I would want you to create some time. You might come around and you look at the physical board, how it looks like, and identify these advanced pins or advanced components that I'm talking about. So create that time and ensure that that is well taken care of. So in this particular slide, I think it's a slide that I'd already shared. I would also want you to try and create time and do the assignments, the exercises, try to bring you up to speed on what basically we have been doing in class in terms of our practicals and so on. So this will also be able to help you understand further on how the configuration of the boards are done. So I would want to go ahead and introduce what you have been working with, like the breadboards, and it's either called breadboard or protoboards. So it's a construction base for prototyping of the electronics. So again, if you have not been able to have a look at the physical protoboard or the breadboards, you can also pass by the labs and have a look at these components, because some of them are here, even though they are not many, but you can have a feel on basically how these particular boards looks like. So we have basically needs to know a bit of the history. Initially, we used to have a board whereby you literally solder everything on it. But with the time, then the issue of the breadboard came about, whereby you just need to push the pins into the board and basically have the connectivity of different components work perfectly without any hitch of loose ends. So you really need to know what are the importance of the boards. Instead of us soldering each and every component, we can have them just placed on the board, and then it's connected to the other devices, and all components can be interconnected and work properly. So that's basically the importance of the breadboard when it comes to the Arduino architecture. So there is a sample breadboard here. You can have a look at that. And this is basically what you've been pulling on your Tinkercad and using. You can actually create time, as I've said, to come and have a feel of how this board looks like within the department. We have several types of boards when it comes to sizes. There are small ones, there are big ones, there are colored, and so on. And if you can look at these, the breadboards are actually labeled properly to avoid maybe mixing the connectivity. You can see you have the red, which will tell you that will be a positive line. Then we have the blue that will actually show you that will be a negative connection. So you need to be very sure when you're dealing with your board to avoid the misconfiguration or misconnectivity. Then you need to know how are the lines running. Are they running diagonally? Are they running horizontally? Are they running vertically? So as I had explained earlier, on a breadboard, that the lines that run vertically towards the line are all connected. And also the lines that runs on power lines on the marked areas, the lines that run horizontally on the top and the bottom are also connected. So, but they are not connected vertically on top. But if you go down here, you realize that this line, they are interconnected vertically, more so on the other larger area of the breadboard. But on the top and the bottom, they are connected horizontally. So you really need to understand basically what's the architecture of the breadboard to help you actually achieve the mission of developing a proper embedded system. So when it comes to doing or interfacing the breadboard with your Arduino system, then there are also other components that come in. So we have the cables, which we use basically to connect the breadboard and the Arduino system and additional peripherals. And so from that particular picture, you can be able to see the image here. There is have the ribbons for connectivity. It has some LED lights. It has some resistor somewhere there. And also it has the Arduino board itself, which is powered using the USB 5 volts or 3.3 to 5 volts USB power. So that needs to be very clear. So you can have a look at that, how the physical board are interconnected. But again, you have done this on Tinkercad, so having it physically, I don't think should be a problem to all of you. So just additional images on how to interface the breadboard with the components with the computer system, how to bring in the resistors and the LEDs connected to the Arduino components and so on. So you can have more advanced areas in which you can be able to interconnect several components on your breadboard and interface it with your computer system. So to continue now, at the end of it all, once you've done your interconnection of all your components with the board, with the breadboard, with the LED lights, additional components, like if you're bringing in the servo motors and so on, then you have now to understand the other component of programming the whole system to function. And that is where to interface software and hardware. So as you also understand how the operating system works, we have the operating system and we have the hardware. So for the two to talk, then you have to, if you're on a Linux environment, then there must be a kernel in between to help communicate between the software being utilized and the hardware that is implementing a specific task. It happens also in this particular scenario, whereby the hardware is there, it's working, you've interconnected everything, but for it to function and automated or to function in the environment of embedded systems, then one of the things that need to happen is that you must bring in the components of software. And there is where we are using the base Arduino software to be able to understand or to tell the Arduino microcontroller that there are components which are connected to you and this is how they are supposed to function. So one of the things that also happens is that once you do your hardware, then your software must work well. So you also need to understand that softwares which are developed on the hardware. Then after certifying that particular software that it's working well, then they are already integrated and it's work. So we consider a situation where the software is developed outside the hardware and that is later being placed on the hardware to function. So that is all about that particular slide that we have there. So the whole integration of hardware and software is done on C. So we're not going to talk much about this. This is something that all of you understand. You understand how compilers work and what are the libraries that are required to ensure that the microprocessor execute the right code to achieve a specific task within the embedded system. So is there any question on the hardware, the software that interface each other to have a working embedded system? Yeah, any question? Yes?
I've posted my question on the chat.
Okay. Yes, I believe that is possible. You can be able to install. Yeah, so Arduinos have very little, if you look at the Arduino architecture, Arduinos have very limited amount of space that it function on. Unless now we use advanced Arduino boards that allows you to add additional storage to your component. So they like the Arduino Nanos, you cannot, Arduino Nanos are still very small. Arduino Unos are very small. So unless you go to the Nanos 33 versions and above, where it gives you the leeway of adding additional components and configure it as a storage. So this make it now more complex. So if you'd want to have a scenario whereby you install OS, then you don't need to use the Arduinos. You need to use the Raspberry Pis, because the Raspberry Pis now gives you the room to have additional space to install the operating systems and so on. But the Arduinos does not have enough space for this particular implementation. So you should also know when you are designing your embedded system, you should know, what am I going to use as my microcontroller? Should I use a small computer in terms of things like Raspberry Pi, or should I use just a normal microcontroller that I can be able to program and enhance, just utilize what's already in place, like the Arduinos. So even the MikroTik routers, they have very small storage. So that will not allow you to do what we call OS, or operating system installation. Edwin, has that answered your question?
Yes, sir, very well.
Okay, thanks. So any other question? Okay. So so in terms of softwares, you should just understand that it's the C programming that is utilized to do most of the coding that you'll be able to use to program your Arduino. So basically, if you understand C#, or C++ well, then I would not expect you to have a problem with programming any Arduino system. And basically, that's also goes to like Raspberry Pi and so on. So that should be very, very clear to you. So an observation that basically I know most of you have also seen that these days the microcontrollers have inbuilt, they are built in. And as you've seen, as we were introducing the architecture of the embedded system, you realize that the microcontrollers are built in on the board, and that makes them fully configured and computerized. So some have virtual machines pre-installed for for Java. For example, you can run Java application on it. This is mainly on Raspberry Pi, but not really on this Arduino microcontroller. So some will run close to normal operating system. So this basically is still not on Arduino, but on the Raspberry Pi, because you cannot do any normal operation on the Arduino, but you can be able to do it on Raspberry Pi. So Arduino applications written in Python or Sketch. So you connect your board to your PC, install an open source Arduino, configure the board settings, write the code, the ID. Then basically that is it. That's what all of you have been doing when it comes to presentation. You've been doing all that. So I think we've passed that, and I just wanted you to get into space and realize that all that you are doing in terms of practical work is what was remaining on this other side of our slides. So again, there's a bit of exercise there that I expect you to tackle and help you understand more on the architecture and the hardware of the Arduino system. I will not go through this again, programming the Arduino system, because this is something you've been doing for several years. You know how to install softwares. We say that it is C-based. Arduino is based, it's a C-based Arduino. And you basically knows how to install and how to run the components on Arduino. So I would not want to look at this. This is something that all of you are aware of. When it comes to interfacing the Arduino board and the Arduino IDE, it's just a USB, which is basically working very well with your simulator, and you can be able to see that controlling anything and everything that you have. This is just an architecture of what basically still you've been doing, the components you've been having, and how they've been working. You are able to configure that, and at the end of the day, all your boards have been working very well with the code running at the back. Those are just a few components that we have, elements that you have been using. The architecture of the microcontroller, what it entails, the number of ports, and so on. A code there that most of you have been working with in terms of implementing a working Arduino system, and so on. So I will not look at that, because this is what we have been looking at in class for the last 2-3 classes. I would want to stop there and take any further questions, because all that what remains on this particular thing is what we have been doing practically in class. So until the end, you'll also find an exercise. And as I had said, please treat these exercises very seriously, because it is just through the exercises that we'll also be able to pick up some few things that will bring in your tests at the end of the day. We don't need to hide that. You just need to know that if you don't do exercises, don't expect basically to get the answers right at the end of the day, because it will just be pulling from one source to the other, changing one or two things from the exercises that I've been giving you in class to do. So I expect you to look at those slides and basically read them and understand what embedded system is all about. So I think from my end, I think that basically should be my last slide. Let me just confirm something here. Yes, so that is true. That will be basically my last slide. So the subsequent slides that come in will be for Dr. Mburu, because he'll be able to take you through the programming part, or interfacing the mobile programming with the Arduino system. And I think from the week after next week, because I think my next week should be my last class with you. So after next week, then Dr. Mburu will need to take over to push through to so that you understand the programming aspect of the embedded system. So my remaining bit now is to finish up with the presentations. At the same time, we have 2 additional assignments that needs to be done. And then from there, I'll wrap it up by having you presenting the projects that you have been doing exactly on the 12th week. So on our 12th week, we should be able to take up and do the project presentations. And again, during the 12th week is whereby I will also give chance to students who have been working on the additional projects that they think can solve the societal problem, that I'll also give them room at that particular time to do that presentation. And basically, we did agree that if a student has taken time to do its own project on embedded system and get it right, you'll be worth 10 marks. So that still stands. It has not changed. It is still on board. So if somebody is doing his own thing, want to implement something that solves the societal problem and would want to present it during the 12th week, feel free. Once you present the projects that you're doing, then you should also come up and present that particular project of yours. So this, by default, will earn you a good 10 marks for you, and you'll be above. So if that is there, I'll create time to be able to assess that particular project and award marks, as I'd said when we are beginning this course. So I'll give room to any question. I'll give room to any question if there is, but if there is no any other question, I will also give room to the few students who had not done their presentation. Last time we were checking them out. So this is the time you can be able to raise up your hand. I take the number. For the next 1 hour, we can be able to have those students doing those presentations for that. Then at the end of it all, I would also be able to give you the assignment that I'll be checking out come next week, because these particular assignments, we should be done with them this week, today and tomorrow. And then when it comes to next week, then I'll be marking a different assignment from the students. So we have Odhiambo starting. Derek, I thought we finished. Was there an issue that remained?
Yes, there was a small issue. You said I should go and correct